groups. Oh, okay. And I'm currently representing Ad Scientist, which is a company based in France that's focused on inverse gas chromatography. So probably haven't heard of it, but I'll hopefully have a time a little bit later to give you a little bit of an update on that. So I'm based in California, by the way.
Great to meet you. Julian, you're next on the script, please.
Hello, so I'm Julien Gibon. I'm an assistant professor in the biology department at UBCO Okanagan, and I'm a neurobiologist. So I really study neurons and the nervous system.
Nice to meet you. Fatima, please.
Nice to meet you.
Hello, I'm Fatima Fard. I'm assistant prof in computer science and working mostly with software developers and any tools related to software.
Right. Richard, please.
Hi, everyone. Good afternoon. My name is Richard Alliong. I'm a faculty member at UBCO in the School of Engineering. My background is in engineering education research. I do research with human-centered design, qualitative methods, and interdisciplinary collaboration.
Great. Kevin, please.
I'm Kevin Bankston, based in Seattle. I'm the director of North America sales for Thermetrics. We make devices for testing textiles. So as most of you guys here know,
Is it the real location behind you? Or is it a photo?
No, it's photoshopped in here, but here's like a neat mannequin right there.
Okay. There you go. There you go. Sunny, please.
Yeah, so Sunny Lee from School of Engineering. My research area is heat transfer and fluid mechanics. So transfer of heat, transfer of moisture. So I do experiments and also thermomodeling as well. Good to see you here. Thank you.
Great. Adam, please.
Yes, good day, everyone. Adam Harris, CEO for CTherm Technologies. We're a group that's focused on developing sensor technology for material characterization, and our niche specialty is really the thermal properties, specifically thermal conductivity and thermal effusivity, which quantifies touch performance, cool touch, warm feel. Look forward to sharing more later. Happy to be here. Thanks.
Great. John, please.
My name is Joan Batorf. I'm a professor in the School of Nursing, and my research area is in the area of health promotion. In the past, I've also done some work in the area of patient comfort during health and wellness.
Good, thank you. Cham, please.
Hey, my name's Cam Stewart. I'm a design engineer at Arc'teryx, background in biomedical engineering, more specifically biomechanics and a bit of physiology.
Thank you. Noemi, please.
Yes, hello, I'm Noemi Dorval-Courchain. I'm an assistant professor in chemical engineering at McGill University in Montreal. I've been connected through CPD through Rob from Lululemon, and we work in my lab on synthetic biology, the intersection of synthetic biology and engineering to make new materials.
Right. Rob, please.
Yeah, Rob Gathercole, research director at Lululemon. I'm in their product innovation team. So leading mid to long-term research in our apparel business.
Thank you. Lucas, you're next, please.
Hi, my name is Lucas Rose. I'm here from sunny Fredericton, New Brunswick. I work with Adam Harris, who's my CEO. We, like Adam mentioned, specialize in thermal conductivity and especially with fabrics and textiles. And happy to be here and nice to meet you all.
Great. Sepida, you are next, please.
Good morning, everyone. This is Sepida Pakpur. I'm an assistant professor at the School of Engineering and an associate member in the Department of Biology. I'm a biologist by training, and I will actually share with you more information regarding the projects I have in collaboration with many of you, actually related to the comfort and the human health.
Thank you. Matt, please.
Hi there, Matt Kramer from Toronto. I work at Defense Research and Development Canada. The Toronto Research Centre focuses more on biomedical science, environmental medicine. My research interest in thermal physiology. So pretty interested in this group and how it might relate to some of our interests in modernizing military clothing. Thanks for including me, Farzan.
Yeah. Keith, please go ahead.
Yeah, hello, I'm Keith Blood from Thermetrics, Director of Engineering over here. I work with Kevin with thermal mannequins and other textile test devices. Just kind of here to listen. All right, thanks.
Great. Anna, please.
I'm here. Sorry, guys. My name is Anna Dixon, Manager for R&D at Arc'teryx. I work very closely with Cam on some of our long-term R&D projects. So thank you for having us here today.
Great. Farzan, you are back. Please go ahead.
Hi, everyone. Thank you so much for attending this meeting. This is Farzan Fodanbeza. I have textile engineering background, and I've worked also on thermal protective clothing, cold weather protective clothing, and as well as working on comfort, specifically thermophysiological comfort. And right now I'm a postdoctoral fellow at the University of British Columbia, and I'm also leading the eminence cluster. Actually, sorry, yeah, I'm cluster coordinator. Thank you so much.
Yeah, you're definitely the main contact and focal point of the cluster. Thanks for arranging all this. So my name is Abbas Bilali. Sorry, I forgot to introduce myself. I'm a professor at the School of Engineering at UBCO Okanagan Campus and Director of Materials Manufacturing Research Institute. So my research mainly is on the textile composites. I'll talk about it later a bit more. But just hearing the diversity of the group, I think when Farzan says it's a national network, this is our first meeting already. I see it how it is national and in that sense actually international. I wish the answer representative and reviewers were here, maybe we didn't have to apply. They would right away accept our proposals with the diversity of the team and expertise. So I think following the agenda, I think next item is for Farzan, maybe just 10-15 minutes max to present what our CREATE program is under this network. And then maybe after that, we can have a few minutes question for him. And then we'll follow with the rest of the items. So please go ahead, Farzan, share your screen.
Yes, for sure. Okay, so do you see my slide?
Yes, we do.
Yes, again, I would like to thank you all for attending this meeting, and the one who will actually see the recording. So I'm going to have some introductory slides, and then after that, Dr. Parkman, Dr. Milani can explain a little bit more, and then we can have some discussions after with the other members. So yes, so it's about create human comfort, and then the main reason is to create strong connection between trainees, academic and industry. So as you may have seen in the application and in the files I sent you, so yeah, it's about create human comfort, and then so if it is successful, so we're gonna have 6-year program with 1.6 million from insert, and so as you see, the objectives are this is a plan. The plan is to have like diverse people from different backgrounds, which will be trained to specialized coursework and multi-faculty research course supervision, as well as having like training from like to have like interdisciplinary settings with training from different backgrounds. And the idea is to have a pleasant and safe environment, as we call environment. We're mentioning immediate environment, which is clothing, and the built environment for food. And yeah, the ultimate goal is also to have transitions of trainees to the career, such as like in like industrial or academic, which would be very specialized on comfort, human comfort, physical, psychological, physiological, and yeah, they would be very highly skilled in this, and so they would be able to characterize each step, evaluate, characterize, and then would be very helpful in terms of the outcome. So so the next program, as Dr. Milani mentioned, is the INSERT Alliance program, which would be the same thing of human comfort, which is a 1 to 5 year program, and then kind of similar objectives to have like some research projects and like collaborations with industry and university. We're going to have transition of trainees to industries and as well, and then there are going to be some broad outcomes such as joint publications, patents, like social and environmental benefits as is required by NCEP program. Just looking at the our CREATE programming at a glance as to have these 4 parts, that new graduate courses focusing on human comfort from these different perspectives, to look at basic comfort, to look at human cognition and design for overall comfort, and then to have some courses of advanced topics. As you may have seen, most of the our participants are from they're dealing with textiles, so looking at somehow a little bit high level textile topics, not look at conventional textiles, but trying to see to get more objectives based on our industrial needs and like environmental industrial needs. Also to have some joint supervised theses and projects and industrial internship toward R&Ds. We're going to have some professional skill development such as workshops and seminars and annual symposium. So we're benefiting from our core team, which is Dr. Pakto as an applicant, and then some of the co-applicants that we're honored to have some of them here in this meeting. And then also just an introduction of Eminence Research Cluster with Dr. Pakto as cluster lead. And so this is ending in August, and we're planning to renew it this summer. And so we have our cluster research team, and some of the project that has been done under this cluster is, so I'm just going to mention two projects. So project 1 is improving thermophysiological comfort in clothing. So there were some publications and conferences based on that. So working on face masks, sportswear, so we're trying to develop also some test methods, or and then as well as doing some simulation and modeling on clothing to predict physiological comfort. So the other part, the project is evaluation and understanding of fabric interaction with skin cells. So which Dr. Pakto will more elaborate on this in her presentation. So it's like technically so far it's an ongoing project. So it's, to look at the effect of artificial sweat on physical properties of sportswear. So that was just small part came from that, and so it's going to be ongoing. And then yes, as I mentioned, Dr. Pakto will more elaborate on this. So we have the support of our academic collaborators from different parts of the world. So this is an ongoing. So apologies if some of the names are not in there, because this is an ongoing, as I mentioned, and then I haven't, I mean, for our industrial collaborators as well, so you may not see some of the names in there. And maybe the other reason is because I didn't get like acceptance, like approval from the industrial partners. So this will be added, and then so we can have a more complete list later. So all of this, again, all of these great brains and then great people and industry. So what we're going to do is to have 4 pillars. So we're going to have, so this is going to be our project. Will be based on these 4 pillars. So cognition and health, material characteristics, which would be more on textiles, from fiber to garments, so fiber, yarn, fabric, garment, and then like surface finishing. So that's the plan is to use our great facilities and then our expertise to do the material characteristics. So we're going to have some technology development, test methods, some like development of test methods and standards, as well as modeling and data science, which would be the ultimate. So we'll be able to predict comfort out of this as one of the objectives of this program. And so yeah, the reason for this slide is to show the connection, interconnectivity between these parts as physical, as I mentioned, physical conflict, psychological and physiological conflict. So this is kind of back and forth, looking at protection, and then from outside, from environment to human, and then from human to out environment. So this is like a circle, and I'm going to explain in the following slides that what we need, why do we need from people from different backgrounds to achieve overall perception of conflict. So that's the aim, and that's the novelty that this program is going to have. So we have some of these facilities. It's great that our investor partner Thermetrics is available this meeting, and then so we have some of them like such as mannequin in the sweating hot plate. So these are some of our facilities. We also have it's a cutting edge multi-sector sweating cylinder, which we're still working on, developing some like testing protocols, and then so it's an ongoing project. We're still working on it, and then so that's a great opportunity. It creates very great opportunity for industries, for like our academic staff and then trainees to work on this. As it is mentioned in this slide, it has very great options for this. So we're going to actually closely see what's going on in terms of different activities, like body mapping, like different physiological responses from which could be predicted from. So I'm not going to go deep on this. So this is just a slide to show that this is one of our test facilities. So we're going to. So this is a slide showing that we are trying to have like developing in all of these stages levels as like physical analysis for looking at bench scale tests, looking at full scale tests, to have something neutral and a controlled like climatic chamber, and then if it's possible going to the following steps. And all of this is to closely simulate our environment, and to just see what we actually need based on end users requirement, and then what they could perceive as comfort. So what would be the requirement and what would be their needs. So just going a little bit deep into this slide. So I have this brand from Brenner's ecological model, and then I kind of expanded that into one of these examples that was in the proposal, which was the patients and healthcare workers. So this is just an example to show that, okay, so if we are looking at each stage, looking at environment, look at the clothing, look at the air gap or human from different perspectives. So if we look at them individually, so we can have people from different disciplines, but when we're looking at this big picture all together and then trying to establish the connections between these environments, So we need some sort of like a holism perspective to look at all of these environments all together. And then that's what, as I mentioned, the required disciplines on the right side. So we need them all, and then so we need to have them connected to have an optimum result, which would be as we're looking for overall perception to get the best like to have like a overall comfort. So as I mentioned, not like discomfort and comfort. So so the other example, as I'm going through this, this is just an example was showing was in the proposal. So looking at sleepers, like the effect of sleepers and under different environments. So looking at like specifically fiber, yarn, fabric, and garment properties. So we need to look at the structure and the properties that will be carried from molecular perspective into the garments, and we need people from different disciplines and then help from different industry partners, so we can get the best outcome, and then just putting it back into the model to actually establish the connections and get the results. Yeah, thank you so much. So that was just some introductory slides. So the next step would be for the answer create. So it's very successful, and then so we're going to have full application submitted in September. And then for Instinct Alliance, we're still working on it. And then so after this meeting, there will be some project proposal forms will be sent to our industry partners, so we can meet the deadline, which would be like very short, in July 20th. And yes, so that's it from my end. And then so Dr. Milani.
Thank you very much, Farzan. I guess, yeah, that this is a kind of general overview of some of the project initiatives, but some of them are like further, like we have some more phases, results, and so on. But I think the overall message here was that, as we all would acknowledge, this is highly interdisciplinary field, and that's what exactly program like Answer Create looks at it. Not to be multidisciplinary, be truly interdisciplinary, in the sense that each discipline has to work from A to Z with the other discipline. If under a physical comfort, myself as a material manufacturing expert start making the textile characterizing without knowing the physiological aspects or user-centered part of it, psychological, there is no point. I'm just wasting my time, and vice versa. And that's where I think we will be very competitive on both of this program, Create and Alliance. And again, the diversity of this team in the introduction, I think, showed that we have the right team in place. So later we can discuss a little bit more about this programs. If there are any specific questions for Farzan or us as a whole, as a program, please feel free to raise your hand or jump in, ask. I see we have a new people just joined us, but probably they can introduce themselves under item 4 anyway. Each of us will have a few minutes to further discuss about our research and interest. So if no question for Farzan, we pass now to Sepide a little bit to discuss about her perspective of the network activities.
Certainly, just give me a second to share my screen. We can take it from there. So please let me know if you can see this screen.
You do.
All is good?
Yes, please.
Okay, again, it's great to be here and talk to all of you. Again, as Farzan clearly mentioned, we have this big goal of focusing on human comfort and actually not only answering the questions of the research projects we currently have with different partners, but also expand on it. And I will let you know why we are doing that. So in general, what we are talking is about human comfort in response to textiles and indoor environments. But before I go into details, let me explain you who I am a little bit more. So as I mentioned, I'm a microbiologist, a biologist by training. And what I do, I look at microorganisms. So what I can call myself a microbiome scientist. And we use omic technologies to understand how my microbes survive, how they respond to environmental factors, and how we can engineer them for the good and the benefit of humans, either engineering them through to get a healthy body, or engineering them to decompose materials. My team is actually encompass a very interdisciplinary groups, and I have members from cell biologists to engineers to neuroscientists, because the research projects we have all have an interdisciplinary questions. So I do have research associates led by myself, or those that they actually co-supervised by different members, including Farzan, who is leading this talk, and who has been co-supervised by Dr. Milani and Dr. Lee. So human comfort, again, I'm going to take you to a big picture and why we scientists actually wants to do any research related to human comfort, because we know that this is a complex, all of us know that it's a complex topic, and the many factors affects human comfort. One of the major factors is the habitat, that the place that we live in, our indoor spaces. The other one is actually has a huge impact is the textiles, our clothing, and both of them actually has a huge kind of effects from different perspectives. So my research actually does, we do have projects under each of these two categories. So for example, for indoor environments, I've been a co-author on the forming the 9 foundations of healthy buildings, because until 2016, I believe that when we were talking about indoor environments, we were talking about energy saving and how to improve the air quality. But one factor was missing in this topic, and that was the health of the occupants. Why that is important? Because all of us are our main habitat is in indoor environments. So we spend 90% of our time in indoor spaces. So what factors affecting our health? Well, we didn't know. We just we had a scattered informations, but not a cohesive understanding that how all of these factors within the indoor environment can affect our comfort and our health. So my research, again, it just has a focus on the microbiome component and the occupants' health within these spaces. But as an example of the projects I have that is relates to the human comfort is the project I have with the company called VU Inc. So we know that the light is an important factor for human comfort in indoor spaces. We know that it affects the circadian systems, it affects our health, it affects our productivity. And what happens, we usually in the indoor spaces we live in, we have this windows, and we think that, oh, we have a perfect lighting in indoor environments. But I want you right now, look around and see that how many of you have blinds in a space? I believe several of you guys, because of the thermal comfort, because of the intensities of the lights, we have these beautiful windows, but we usually have blinds down. And what does that, how that impact our health? We didn't know. We wanted to understand that how just type of windows and type of lighting within indoor spaces affects our comfort, affects our productivity. And the research showed that those workers working in offices with blinds, they have much lower productivity compared to those that they actually have these smart windows that they get tinted, they bring natural light into spaces, but they reduce the actual heat in indoor spaces. So the next question I wanted to understand that this is a systematic systems that they are not, all the components are not separated from each other. And one of the components is the microorganisms that exist in indoor spaces. We wanted to understand that how by changing a type of light in indoor spaces, we can impact type of pathogens we have in such spaces. So these are the, again, I'm going to just briefly show you some results that if we are just focusing on the pathogens within indoor spaces, that we keep cleaning the spaces, we keep using detergents to get rid of them, I wanted to know that does light can help us to disinfect such spaces without bringing a chemical component? Can we consider light as a disinfectant? And so we went forward. We have defined several projects, but as part of this project, we have built this some kind of indoor environments within our labs. So this is a system that we call it is a smart. It has different type of windows around them that it goes from a natural windows to a smart windows with different tint and levels. And we do have this solar simulator on top that actually act as our sun, and type of lighting we have in this environment is exactly the same as what we have in indoor in our offices right now or in your houses. We wanted to understand that, okay, if as we change the indoor type of windows, how type of light changes in such spaces, and this drastically changes. We know that, for example, in the EC glass, this is a clear, this is a regular window. As we have a really high intensity light. That's why we usually have blinds in place, and also we have a spectrum of the light. As soon as we put blinds in place, you can see that we reduce the intensity, but we are bringing more of the red light, infrared lights into spaces. But by tinting them, by actually chemically changing the surface of these indoor spaces, we found that we are bringing more blue light in indoor spaces and less of the red light. So that was another question we wanted to know, that how impact the pathogens, and then we tested it on different fungal spores, we tested it on different bacterial spores, we are testing it on different viruses, and we are showing that light is a great disinfectant. By changing windows, you can actually impact the type of viruses, type of bacteria that exist in indoor spaces. But the next step, we are not alone. This is not only us and indoor spaces. We have different materials in such spaces. And does the viability of the bacteria changes as soon as you change the surface materials or the textile you're bringing in? And that the response is yes, depending on the porosity of the materials, type of materials, and physical kind of surface properties, the viability of microorganism changes. So it changes the whole idea of healthy buildings. So this is a systematic approach. We need to bring textiles into spaces. We need to bring indoor building design into spaces, window design into spaces, and also looking at the microorganisms and understand how all of these affect human comfort and human health. So for some of you who may be interested to understand that, okay, how we assess the microbial growth, this is a very simple method where we do more advanced technologies, but you can see under blinds 1%, we can get all of these dishes, any dots you see, these are actual active bacteria. As soon as we bring high intensity light, we get rid of them, but light is actually it affects the human comfort. We wanted to actually reduce the intensity, but at the same time get rid of the pathogenic microbes. And then by tinting them in 1% and reducing the light intensity to 1%, we showed that bacteria can grow much small, less than when we don't have them in place. So this is a snapshot, only one example of the projects what we are doing, focusing on the indoor environments, but how the textiles can actually and clothing can actually come into the picture. So as I said, we are coming in indoor spaces with our clothing that impact our comfort and that impacts our health. And we want to know how the actual textile, the actual clothing can impact human microbiome, human skin microbiome, and also the actual skin immunity and health. So this project is in collaboration with Lululemon, and again, I can't share details of the results we have because it is ongoing and it's not published yet, but still anyhow we know that why it is important, because the fabric market is growing, and also through pandemics we've learned that how that can impact the human health, and then actually fabrics can actually encompass microbiome specific pathogens, and they can impact human health. But we first ask a much bigger question. We want to make sure that these fabrics doesn't affect our natural microbiome. That is very, very important, because yes, we want to kill pathogens, but we don't want to kill all the good microbes we have on our skins. And at the same time, our skin microbiome can actually grow on the fabrics, degrades them. It can actually generate odor. It can generate many kind of compounds that actually impacts the comforts of the humans and actually health of them. So we are asking this kind of very complex question to understand that if you have a specific fabric, how it impacts the microbes, how it impacts mechanical properties of the fabrics, and how it impacts the skin health, skin immunity that it's missing right now in the literature. And all of them, we want to hope kind of continue and understand that how can impact mental health of the occupants or the users or their cognition levels. The next step and a follow-up question would be that, okay, we have these healthy textiles, we want to make them antimicrobial. We also do that. We are doing a project with the pre-labs, and we wanted to just kind of move on to make healthy fabrics to that actually not only nourish the good microbes, but actually kills the pathogenic ones. So again, this is a snapshot of the results. I can't share more details about them, but anyhow, we have tested different antimicrobial properties. We found those that they actually can kill microbes, but are they healthy? Are they healthy for our skins? I would say no, because all of them are toxic. And we found that the dyes we have on the fabrics can kill the skins, and actually it has drastic impacts on the human skins. So these are the snapshot of the projects. I want to discuss more details with all of you and see that what else we can do. But anyhow, these are where some of the building blocks of forming of our human comfort cluster. With the help of different faculties on this campus, we want to move forward. We believe that the definition of human comfort needs to be redefined, and we need to bring the concept of health into the picture. We need to understand how healthy buildings, how healthy textiles, and also how healthy cities can actually impact human comfort. And I hope that we can continue this discussion with you guys and then understand and just kind of define more projects or get your valuable comments to get closer to redefining this very important concept, which is human comfort. Thank you, Abbas, and we can actually move on to the next step.
Thank you very much, Sabita. I guess, yeah, that was very useful to give a non-engineering perspective. I think that last slide that speaks it all that it's more than textiles comfort. It's really the interaction of human also with the environment and the bigger indoor and outdoor. And that's where, again, I think interdisciplinary approach is really key. Like two messages I guessed from this is not only interdisciplinary, it's a really system level approach that adds to that interdisciplinarity, but I can't just imagine like better that how our students will really benefit from these projects and courses, because just imagine, I think the main bottleneck now in industry or academia that each lab individual is isolated on one of these aspects that Farzan is presenting, Sepide is presenting, but not as a system level. Because that requires that 5-6 faculty from different departments teach the same course, because that requires that the same project has sub-project with 3-4 industries, each with different faculty, and they work together and learn. Not only students learn from each other, faculty and industry learn from each other. And that's where I think, again, the value of such program like Create is very competitive, but I think we are in a very good position, hopefully, same as NSERC Alliance. So if you have any specific questions for Sepide before we go to next item, please jump in, speak out, or raise your hand. Okay, so if not, then let's go to our now individual presentation. Again, as Farzan mentioned in the email, either you can share a few slides or verbally explain a little bit about your research interest or ongoing projects or the ones that you would like to work on. Maybe we limit it to 3 minutes so that we leave it 2 minutes for question chat for each individual. So who wants to go first? Maybe we go with the list of participants on the right side. Adam, do you want to go first, please? Adam Harris.
Sure, yeah, no problem. I'll see if I can share my screen. Okay. Real quick introductions to who CTherm Technologies is. We specialize in material characterization, particularly the thermal properties, thermal performance testing of materials. So, you know, what I saw in some of those earlier presentations, the work done on the material development, different coatings, different application conditions. Think of like moisture, sweating, wetted conditions. These are all areas that we have some experience and our clients have are applying the technology in to measure the thermal properties. And what we provide is really a yardstick to quantify that thermal touch property in fabrics as well as thermal conductivity. So I'll just kind of give you a little bit of an illustration of what it looks like, but this is what the TX system is. It's got a sensor, it's a one-sided interfacial sensor. I'm not going to detail the full theory of it, but you basically have a compression test accessory over it, which controls compaction, because one thing that's really influencing the thermal properties, the effective thermal properties, is the level of densification. And so this is an important consideration. What we measure directly with the sensor is 2 thermal physical properties. The first one's quite commonly understood, thermal conductivity. It describes the rate at which heat energy transfers through a material under 2 different temperature gradients. But the other property that's really interesting, a bit more novel, is thermal effusivity, which is the square root of the thermal conductivity, density, and heat capacity. We measure that as a bulk number. And what's interesting about that is it's defined as a thermophysical property that determines the interfacial temperature when 2 different materials come in contact. So if you think of your skin coming in contact with different types of material, it's the effusivity that defines what that interfacial temperature is in the initial contact. So if you think of like getting out of the shower in the morning and your feet hit the cold tile, that material has a very high thermal effusivity. You jump over to the mat, that material has a low thermal effusivity. And the value of this, it helps a lot of our clients with material selection, with formulation development, providing rapid feedback on how changes in coatings, texture, other aspects of how the materials are put together, to have something quantifiable quickly, to be able to measure that thermal feeling and quantify it very precisely. This is also starting to be introduced more and more in marketing claims. We're seeing a lot of use in bedding, for example, where the cool touch is a key aspect of how the product performs. So basically, you would want a higher thermal effusivity in this range. We've done and gotten to know Farzan a little bit through some collaboration at the University of Alberta, where there's an active project looking at wetting and some procedural aspects to controlling the application of the moisture. But water has a very high thermal effusivity relative to most textiles, 1600 relative to about a range of 100 to 400 or 500. So you get a sense a little bit of the scale here. We work with a broad range of clients. So I just picked one just as an example, Adidas. He works, Dr. Christian Haid works in the Futures group there. So they're working on product that they're trying to bring out in 3 to 5 years, where Cool Touch is an important aspect of performance. But this was all Canadian developed technology. And the first application of it was actually with Mark's work warehouse. From Canadian Tire. So we have most of our clients are outside of Canada, but we do have this really interesting experience within Canada, working closely with Marks and other groups such as the University of Alberta and advancing the body of knowledge on how to characterize some of these material properties. These are some qualified test labs that offer this test standard that have the C-Therm apparatus. So Bureau Veritas, TTRI, Intertech, etc. We just recently are concluding a project with Susan's group at the University of Oregon. This was a collaboration that included clients at Under Armour, PVH, which is Calvin Klein, Tommy Hilfiger, Columbia Sportswear, and Marks. And the purpose of that was to combine some of this research with the tactile touch of a human test panel and correlate some of that. Susan's just recently authored a paper on that. It's quite interesting. So that's a real quick blast on what we do here at C-Therm. I guess, to maybe just express our areas of interest, where we think we could add value. It would be really centered around anywhere where you're modifying a textile and you're interested on what those modifications are like when it touches the skin. We do a fair bit of work in biomedical as well, implants, transdermal patches, stuff like this, where we're concerned with what the feel of the material is on the skin. If it touches your skin and you care about what it feels like, whether it feels warm, in the case of long underwear with Marks, or you want a cool touch in the case of Columbia Sportswear or Under Armour, that's what we do, and that's where our strength is.
Thank you very much, Adam. Very, very interesting talk. Any questions, suggestions for Adam? Of course, later we can get in touch through emails and so on, but if any specific questions. Definitely the measurements, I think, is the main first step of any research project that we do, and I see that's already you have collaboration with universities. That's really good. I just wanted to add, by the way, this network is not limited to this group. So by any means, if your other collaborators, other professors, or other industries, please connect them directly with Farzad, and so that we can include them in the email list for the next meetings.
It's great timing too, because we're just trying to discuss next steps with Susan's group, and I think this would be a really nice fit. And that pillar of the, you had those 4 pillars up. It's the material characterization. I think it fits really well in that area.
Exactly, yeah, and it perfectly matches also our simulation experts, as we will see in some of the other presentations.
One last thing, very interested in any work done, anybody bridging out into electric vehicles. There's a lot of really interesting novel work being done because of the different dynamic there of climate control in an electric vehicle. You don't have that combustion engine. You're seeing some new material development and some really interesting novel approaches there, and that's something that we're also very interested in.
Just an FYI, this is Kevin from Thermetrics. We are highly involved with the electrification in vehicle testing and the HVAC system and radiant energy and reflective energy, so on and so forth. So we're highly involved with that group, so that I can definitely talk about that and bring some of that to light. So
that'd be great, Kevin. And we have a common collaboration partner with Thermal Analytics. They might be somebody also to bring into some of these discussions.
I've already written down that I'm going to talk to Craig about it. So he's going to be here next time. I promise you that. So
cool, awesome.
And I'll get into that once I get into my small presentation. So
okay, beautiful.
yeah.
Incidentally, actually, you are the next in the list, Kevin. Please go ahead.
All righty. Well, I'm going to share my screen with you guys. Let's see if this is going to work. Share that thing. All righty. Can everybody see my slide up here?
Yes, we see a website. Yeah, it says,
So
yeah.
it's on our website. So this is
Yeah,
all
please go.
available out there. First off, Farzan, thank you for teeing this up for me. I have to say thank you for that. And I also want to say that, you know, C-Therm and us, we really see, even though we both make equipment, we really see each other as complementary. I'm in conversations with your guys' people all the time. So just got one today. I don't know if you're even aware of that. But with that being said, Thermetrics, we look at everything from thermal and moisture comfort, but it all comes down to the thermal side of things. So first off, I think that's where we can add a lot of value is, you know, we don't do anything from, so first off, let me explain the slide that you're looking at. We've got one-dimensional testing is what we call it. We call this the testing continuum. Two-dimensional testing is that cylinder shape that we were talking about. Three-dimensional is mannequin testing. We have a fourth dimension that we can add, which brings realism to the mannequins through a co-developed physiological model that we did with TAI or thermal analytics. Thanks for that, Adam. And finally, we have to tie that all the way back to the end user and their experiences across the board. So you can see that we can test everything from a thermal standpoint, from flat sheets of material or stack ups, all the way through the spectrum. And that's kind of where we live. You can see that the two arrows are around the bottom. You know, we don't do so I should say we don't do yarn or fiber testing. I call that kind of the 0D, if you will. But from here on over, flat sheets of material, you're always going to have perfect contact with your surface. No air gaps will be introduced. So as you move from one-dimensional all the way through the 5 dimensions, you get more realistic, but often more variables added to it. So as an example, perfect, anybody can lay a flat sheet of material on a flat on a flat table, right? So you get that perfect surface contact. Great for testing material properties, but now you go to a stretch material, and you want to be able to, how is that stretch material actually worn? Really hard to test and get consistent on a hot plate by making a simple tube. And this is that exact same device that Farzan had shown. This is a collaboration with IMPA that we've actually done. And this is the IMPA cylinder, our redesign of it, that you basically sew a tube and you pull over the top of it, and now you can have a certain amount of stretch to your fabric and test it in that environment. So a little bit more controlled because you get that even stretch all the way over the material. But it isn't how a human is going to feel it, because a human's not going to feel it the exact same way. So, and fit is so important because air is a great insulator if you keep it still. So anytime there's an air gap, these mannequins are sensitive enough that they are going to be able to measure not necessarily where the air gap is, but that extra resistance in that area. Once we go to the 4th dimension, now we add the physiological control and comfort model to that mannequin. So now you dress a mannequin, put them in a specific environment, and we actually can actually set an activity level. So the mannequin will have this met rate. He's running a marathon. He's sitting on the couch. He's sleeping. He's doing this. We could add simulated basal constriction, basal dilation to this. Mimic the heating effects of shivering as an example with this model based on his external environment. So we've got a lot of the, how do I put it? A lot of the aspects that we're talking about already built and integrated into some of our systems. It's just now a matter of taking on some of those other things that we were talking about, the psychological approach, the human indoor factors of what you're seeing, so on and so forth. And being able to break those down. So a thermal mannequin, what it can do is it can measure how much energy is being lost to the environment through the clothing or whatever it happens to be. He can measure that, but he can't break down what is the mode of energy. So if you're sitting next to a window and you're getting that thermal load, he says, oh, I'm not losing as much energy in that particular area. So for the automotive industry that we talked about, we have one that we can actually take this mannequin, put him in an environment, and actually measure the different modes of heat that are coming in. So I'm just going to zoom in here just so we can take a good look at this guy. So what we have is this guy is a mannequin, unclothed, but he's used for testing environments. Underneath each one of these little black caps is a wind speed and a temperature sensor. These little round circles that you see here, those are radiant energy sensors and reflective energy sensors. So it measures the amount of radiant energy that's coming in. And if you sit next to something that's dark, that's actually reflecting energy back to him, he's going to actually measure that. So we get the different modes of heat going into this guy. So we can actually measure environments. In addition, there's also RH sensors all over this guy. So he's an array of sensors to be able to measure environments. I just want to make you guys more aware. The thermal mannequin can't distinguish where he's getting the energy from. He just says, hey, I'm losing less energy. Whether that's through an energized garment, whether that's through whatever it happens to be, he says, oh, I'm not losing as much energy, so that's all good, right? Or that's bad because I want to lose the energy. So it's that whole balance there. So I just want to let you guys know that this is in our comfort in our wheelhouse too. Yeah, as far as a little bit more about Thermetrics, here is spurred on by Adam's presentation. I wanted to just give a brief, a broad brush stroke. This is just a small little amount of the places we work with, but we work with quite a few different places across the world. We're on every continent now except Antarctica, but I don't know anybody that's doing testing there. So there you go. Questions?
Thank you very much, Kevin.
I tried to go fast. I could talk about this stuff for hours.
That's
if you want
great.
to talk about it for hours, call me and I'll talk to you about it for hours. So
Very nice talk. Already I can see again for a program like Create, normally we have invited guest lecturers from industry for students. I can already see like how nicely these talks will come together for students as well.
One last little note I wanted to put out there. We are also working with other universities right now, which I'm going to put them in contact and invite them to the group, where we're working on the healthy cities aspect of things with different heat islands that are being created in these different metropolises, so on and so forth. And they're using our mannequins for the massive heat loads that are coming in there. So we got a broad brush stroke of who we are, what we do, but if a human can go there, we've got a mannequin that can measure that thermally. I'll just put it that way. So
wonderful. Any quick questions, comments for Kevin? Okay, so I anticipate we'll go a little bit over time, probably stay because the meeting is up to 1:30. It's really great talks. I don't want to interrupt anyone. Probably we'll go closer to 2. If anyone has to leave by 1:30, please just raise your hand. You can go next first before. Otherwise, we go through the list.
I have to drop at 1:30, so as long as I can go
please
before
go ahead, Piers. Yeah, so next we go with Piers, please.
Great. Well, good to meet everyone on the call, and thanks for the presentation so far. I think that Sepida did a great job kind of walking through our technology to some extent as it relates to the infectious disease and bacterial growth and virus growth. And we've been really fascinated with the work she's done, kind of exploring how daylight impacts those factors. Maybe I'll spend a couple minutes just talking through the product itself and give a quick background, and then I'll just open up for questions. Just my role at the company, I'm the VP of Health Strategy, so I get to lead these research partnerships with academia. I worked with Sepita at Harvard before joining View. So we were both kind of postdocs at the same time in the same program, and that's how I got to meet her and work with her initially. And then when she came here to UBC, I came to View, and we've continued to work together through this research partnership. Let me bring up my slides. 1 second. All right, can you all see that?
Yes.
Great. So we're founded initially about 15 years ago now, and we've over the past 10 years have really scaled up our product. Essentially, it's a smart window solution that tints. That's what Sepida showed. So instead of having blinds, you have a dynamic facade. We have 1,200 patents that we've filed. We've done about 600 projects. For those of you that are in Vancouver, we've done about 20 projects in Vancouver, including the new ITC hotel that's there, along with several others. We've also done a couple projects in Kelowna for that campus. So you can find us in pretty much anywhere in North America. Done a lot of airports too. So you've probably seen our product without knowing it, just flying around through Canada and the States. Here are just a sample of some of the projects that are more notable for us. We're doing major aviation projects, major office projects, a lot of life science. Healthcare is a big one, especially when it comes to infectious disease, as Sepida mentioned. Pretty much every type of building that's big we'll do, and we do the windows on those buildings. The way the product works is it's an intelligent tinting window. There's an inorganic material that's applied on the inside surface of those one of the panes of the 2 panes of glass that are in a typical window unit. And when the facade is exposed to sunlight, the technology tints itself down so that you can control for glare while still maintaining the views. So you always have a clear view outside without having the glare or the thermal discomfort. We block about 90% of the heat gain when we're tinted. So we also save a lot of energy, both in terms of reducing the cooling load of the building by not having that excess heat come in, as well as by reducing the lighting requirements. So when that daylight harvesting can reduce the amount of lighting that's needed. The way the windows work is we have a network that goes to the whole skin of the building. Every window has its own IP address, so everyone can be controlled individually. In addition to our intelligence, we give our users control, whether it's to an app or schedules, to control the system as they like. This shows the kind of the range of the tint states, ranging from a typical window down to the darkest tint state, which is what Sepida tested in her case, and found that there was that disinfection potential even at 1% light transmission, and with 90% of the heat being projected from the outside. The building itself the glass itself is controlled through an intelligent system. We mock up all the buildings in Revit in a kind of 3D model, and then we also model all the surrounding context. So when the occupant moves into the building, it's accounting for the position of the sun relative to each pane of glass, and it's tinting it predictively based on when the sun's going to come around and expose that facade. We account for reflections off of existing buildings, off of water features. So there wouldn't ever be a scenario where you have some type of glare that comes in. We're accounting for all those different elements where you might have that. We also put a sky sensor on the roof. So if there is cloud cover, we're able to clear the glass so you always have as much daylight as possible when there's not the potential for glare. And I'll stop there. I'll save you the video since I went through most of it. Any questions on View? And I know a lot of you are on the more of the clothing factors, but with Sepida, we've been really keen on looking at environmental factors too. But happy to field any questions.
Very nice talk, Piers. Any quick follow-up questions for Pierre? Again, I can't just imagine how many projects and opportunities are there. The moment you say built environment, textiles, any combination, given the variety under each and the number of factors. So I just was thinking loud, like what Kevin presenting, one of those HVAC mannequin, imagine we put it in the buildings or rooms that Pierre was talking. Let's look at that aspects and then connect it back to what Adam was saying about textile properties. Just that would be by itself a complementary case studies to what has been going already from the biological aspects, the microbiome and so on.
Absolutely.
But
I
just-
didn't really mention it, but with thermal comfort's a big benefit of ours. Since we block that radiant heat, even if it might be the same air temperature, it's a very different fuels temperature when you're sitting in direct sunlight, and we block that radiative heat and kind of really make the thermal environment a lot more comfortable.
And then add the psychological part, like two person, the same condition, the same clothes will have two different feeling, right? Exactly,
Yep.
okay, because of their memories.
Mhm.
Wonderful. So if no other comment, questions for Peter?
Can I?
Please, Fatima, you go first. Again, whoever wants to leave like.
Oh no, there is no question. I just wanted to go next.
Yeah, please go ahead.
Yeah. Okay. So let me share my screen too. Okay. So hopefully it is visible, otherwise I would hear something. So I'm an assistant prof in computer science department, and my research area is pretty different than all the discussions that is going here. So I'm a software engineer, and we do natural language processing and AI techniques for software engineering field. To give you some examples of these things that we do is that we mine user feedback on different websites, or for example, any bugs that is issuing, or for example, all of you have apps. So when you're not satisfied with your app or other users, you would put something on the Google Play or other app stores. And then we mine these, one of the projects, one of the teams in my lab is that we mine these user feedbacks and then find the issues that the users are actually discussing about the app. So is there any issue? Is there privacy issue, security issue? Is there some bugs, etc., etc.? And this is not only related to user feedback, but there are a lot of other knowledge that software developers are putting here, and they're asking questions about the code, etc. So we mine those repositories to find out what are the problems that are discussing, and then how we can make the software development process more comfortable for the developers. One of those aspects is specifically the intelligent source code analysis, where you can think about that. Some of you, I'm sure, at some point of your education, at least, or your career, is still doing some writing some code. So one of the issues in software engineering is how to manage this kind of code. And when the new developers, like when I'm talking about the most human comfort theme that we're discussing here, is that when people are discussing are new to some code, or when they are writing code, what can we do? What kind of tools can we develop to make them more comfortable in this process? And that falls under the area of intelligent source code analysis and then natural language processing. So as part of these things that we are doing, we are finding, like for example, one of the things that we are doing is we create comments for the code that is written, which is mainly for program comprehension and then confidence and ease of use of the new developers joining a team. And then we are doing a lot of other AI related works related again to software engineering, how we transfer some knowledge to programming languages or to other tasks that are we don't have a lot of supervised data or to train the machine learning models. As part of our works, we also do develop tools. Some of them are visualization tools, when we also have developed some topic modeling algorithms, when we can extract different topics from various versions of the data. Let's say you have a system with different, and then you have different releases. So users are continuously writing about your program or about your software or your app, and then how we can mine if there is an issue in the previous version which was solved in the new version. So how we can keep track of these user feedback. And this one is also another tool that we have developed that is related to the comment generation and then for the coding environment. So we also collaborate with different industries and universities in my lab. Some of them that you see up at the top, such as Charlie AI and Scroller, are mainly related to natural language processing, and some of them are mainly related to source code, which is, for example, JetBrains. And we also do a lot of collaboration with Dr. Milani's group, and also with different universities all over the world. So I think I'm just stopping here, and if you have any questions, I'm happy to answer.
Thank you, Fatima. Any questions, comments for Fatima? I guess given the scope of, again, system level complex project, the data management and data processing is a big part, and I think the expertise of Fatima comes there from computer science. But just from the some of the side project, for example, that she mentioned, few shot learning, that's very critical, because sometimes, when you want to, in this context, do a new textile, design it, or be a new condition built environment, that is very expensive to do experiments each time, or time consuming. That's where future learning comes. You use the historical data or lower or inexpensive data from the past, and then try to bring up an AI model that for the new case needs just one trial, or sometimes these are zero-shot training, no trial at all. It will predict the new condition. So that made huge difference in my field when working with aerospace industries and other, in my field, composite manufacturing, for example. But I can see very well those type of algorithms that she described will apply to this group as well, especially when we go to the human trials, where the variety will be a lot uncertainty. Definitely we need data models.
Abbas, do you mind if I go next? I have a deadline here myself. So.
Please.
Okay, thank you. Mine's not going to be very long anyway. Let's see here, which one? This one. Okay, is that
just uploaded?
Are you seeing it now?
It's just coming a second. Yeah.
Okay.
Oh, there you go. You see it. Yeah.
Is it good now? Okay, great. So I guess real quickly, the company that I represent, Ad Sciences, deals with a technology called inverse gas chromatography, or IGC. I would imagine a lot of you probably have never heard of it, but it definitely fits into the second pillar of materials characterization. So at a very fundamental level, the technology can look at basic fibers, individual fibers or bundles of fibers, and what are the physical chemical properties of these fibers, and also looking at the actual materials, woven, non-woven materials, what have you. So this is in essence what the technology is all about. So let me just show you real quickly. The company's based in France, near the Alsace area. Basically, the focus is really on software and taking existing technology, like gas chromatography technology that you can find out there right now, and also technology for actually moving vapors into the system, so auto sampler systems. We bring that together to do with this experiment called inverse gas chromatography. And just this slide, sorry, it has a lot on it here, but very basic. What IGC does, contrary to traditional gas chromatography, it is actually trying to get some physical chemical characterization of the material. So we invert the role of the stationary and mobile phases. So again, regular GC, is allowing you to figure out what's in the column, okay? But we're doing the opposite. So we'll take a column, it doesn't have to be a column, but usually it's a column, and we'll pack it with our material of interest. So that could be a fiber bundle, it could be coated film, any kind of surface, as long as you can get it in the column, or you can also do it in another way, a flat surface device, which I'll show you in a moment. But basically what we then do is we can then inject up to 45 molecular probes that are well known. So a series of straight chain alkanes, branch alkanes, cyclic alkanes, what have you. So it's almost unlimited. So by injecting those one at a time through the column, we can then measure the retention time, okay, which directly relates to a whole range of physical chemical properties, surface energy being one of the more important ones, which you could think of surface energy as very much equivalent to surface tension of a liquid, but we're talking about of a solid surface. So, how hydrophilic, hydrophobic is that surface? If you put a coating on it, how does that change? What is the acid-base properties, diffusion coefficients, TG? We can measure desorption isotherms, surface area. So it's a whole bunch of things you can do. It would take a long time to explain it all, but essentially we can do that either as a vapor injection. We can take the headspace off of the probe molecule, or we can even do an actual liquid injection into the column, and then using traditional FID or flame ionization or TCD, thermal TCD detectors, if you're using water, for example, that's how we actually can determine the retention. We can measure the retention time. We can do it as a function of temperature, a function of relative humidity, what have you. So again, it would take a while to go through everything, but one more slide here. Well, okay, a couple more. So this is the planar surface device. So I showed you about the column. That's a traditional way of doing inverse gas chromatography, but we can also have this planar surface device where we can actually lay down a fabric, okay, right in this separate device. Again, temperature controlled, humidity controlled, whatever, and we can pass, again, the vapors through that device and then measure the retention time. So it's a lot of things you can do with it. It's almost unlimited in terms of the stuff you can get. But this just kind of shows a quick picture of what the device looks like. So there's this auto sampler sitting on top of the gas chromatography system, and the software just controls the whole thing and does the analysis. So just last slide here, just something that we were thinking could be quite helpful for this particular project. So measuring the surface area, is normally done just with nitrogen at 77 Kelvin, but it's quite useful to do this using other molecules like water even, or organic molecules. And one of the unique things about this technique is that it can be done at normal sort of relative room temperatures, if you will. So surface area at room temperature instead of at 77 Kelvin, which is how you do nitrogen surface area traditionally. But more specifically, if we look at it in terms of the hydrophilic portion of the surface area and the hydrophobic surface area, and then we can look at the total. So this is a very kind of unique way of looking at it. And we think that this could be quite useful for this human comfort project in terms of especially the fabrics and the coatings that you're putting on them. I know someone talked earlier about a military application, so certainly that could be useful for that as well. So again, a lot we could do. I'd love to talk offline with any of you about any of this, but hopefully this could be a decent contribution for the project.
Wonderful, thanks, Joe.
Thank you.
Maybe a very quick question, Sepide, do you have any?
Yeah, so thank you very much, Joe. This is very interesting and very much needed. And I just wondering, is the company, do they only sell the equipment, or do you also provide services?
We can also do services, yes. In fact, the company started out as a service organization, contract service. That's since 2000. So they've been, and it's exclusively IGC. So this is what the company does. In 2017, we started to actually sell the actual software to actually do the experiments, at a customer site. So we can support either way. But if you already have access to a GC, especially if it's made by Agilent or Thermo, then chances are we can just take what you have and then just have the software to actually do the analysis on site. So whichever way is fine.
Got it. And my next question is that in terms of the chemical compositionality, I just kind of, can it get at the fiber level? Because this is amazing if you can get it at the fiber level. Can you, is it just kind of distinguish the percentage of the lignin to cellulose to hemicellulose, or is it not at that stage?
That's a good question. I don't know that we could do it at that level, but certainly, really any kind of fiber, as long as you can pack it into the column, or if you want to use it as a fabric, you can actually put it in the planar device. But normally you just pack it in the column, and then you would just pass the various probes over it. So I mean, maybe if you did some clever math, you could perhaps get at the level that you're asking, but I'm probably not the right guy to answer that. But I know people who could, though.
Yeah, that's great. That's great. This is very interesting. Thank you very much.
Thank you.
Okay, Rob, you can go next. I know you have to leave as well by 1:30. Briefly.
Yeah, thanks, Abbas. I can probably be quick. I don't have any slides. I assume most people here know Lululemon, and I'm probably not going to share anything that you don't already kind of know. We work with a lot of you on the call already. Our interest is in product innovation, is in the future of materials, the future of manufacturing, the future of human performance, and the future of well-being. So our team, our R&D group is about 40 people. I'd say there's about, I think last count there's about 12 PhDs on the team. Most of those I would say are in the domains of thermal physiology, biomechanics, neuromechanics, so more on the human side. Obviously comfort is very important to us, thermal comfort, but also I don't know what you would also carry, maybe physical comfort. I don't know. I think there's a lot of opportunity here. I think we've always kind of emphasized the complexity of comfort. My background is probably more in thermal comfort, and it's a domain ruled by thermophysicists and thermophysiologists. And I think it's a much more complicated domain than that. And I think everybody's beginning to recognize that, and I think it bodes well for the future. So thanks everyone.
Thanks a lot, Rob. Yeah. So anyone else has to leave? Yeah, Matt, do you want to go?
Yeah, would anyone mind if I go next?
Please.
Okay, thanks very much. Like Rob, I don't have any slides, so you're stuck looking at my basement. So a quick thank you to Farzan for inviting me to this meeting and to participate in this initiative here. So as I mentioned at the front end, I work for Defense Research and Development Canada, which is an agency within the Department of National Defense. And DRDC is the primary S&T delivery vehicle for the Canadian Armed Forces and National Defense. And we also partner occasionally with some other government departments, but the CAF is our main priority. We have several labs across the country, but being based in Toronto, our focus is fairly narrow on the environmental medicine space, as well as some aspects of ergonomics. My research specifically, I operate kind of in between two different research sections at our center. One is the military health group, where we have some interest in elements of soldier health. Some domains include traumatic brain injuries, mental health, hemorrhage, that sort of thing. But I think as it relates to this group, some of the work that we do on the integrated operator performance side of things, which includes ergonomics as well as primarily for me, thermal ergonomics, is most of interest. one of the long-term initiatives that we have on the horizon is the modernization of the military's suite of clothing. And one of the major issues that we have is that we don't really have a good baseline assessment of how the current suite of clothing, or I should say, the biophysical properties of the current suite of clothing. We do have some information about particular garments that are for very unique environmental circumstances, but not everything. And so as we proceed towards this modernization, we're kind of, unfortunately, we may not really know where to start because we don't have a good baseline. And that's actually how I got linked up with Farzan, some of the work that we're trying to initiate to establish those baseline characteristics. We're hoping to work with that group. But yeah, as far as research priorities and objectives, we see things from the perspective of we have a thermally stressful environment that military personnel often work in. That leads to severe physiological strain that moves downstream towards environmental injuries. At this time of year, we're always keeping our ear to the street to learn more about heat-related injuries and illnesses. And for me, I'm quite interested to know how our current clothing and equipment ensembles may contribute to that effect. But we're also focusing on discomfort, which everybody here knows has significant impacts on performance. And for the military, one of the first things that we want to make sure is that people are as comfortable as possible so they can operate as effectively as possible. When effectiveness drops, objectives aren't met, and there could be very dangerous consequences. So discomfort is a key step in there. And that's why I'm quite excited to be included here. As far as it relates to the NSERC Create grant, DRDC has a long track record of supervising students in various capacities. We've had everything from undergrads come over for brief periods as co-ops, and then people have completed postdocs under the supervision of defense scientists at DRDC. So we have a track record with training and development, and we have excellent facilities, which would be a great training ground for anyone who may want to work with us on some of the research objectives that we have, or that you have, or that we collaboratively share. That's all I got. I'm happy to entertain any questions. And thanks again for inviting me.
Thank you, Matt. Any questions, comments for Matt? Definitely, as Matt mentioned, like we have already had some projects in the past with different faculty across the UBC with the RDC. And this I'm sure it will be a great extension to those projects.
Agreed, thank you.
Thank you. So anyway, let's go next, because we are recording this and we'll share with all those who had to leave and the one that couldn't meet. Who wants to go next?
I can jump in. And maybe
please jump.
It makes sense too with Matt and Rob. I think
your voice is a little unclear. Maybe speak closer to microphone or change the microphone.
Can you hear me any better now?
Perfect. Yeah, please.
Is that any better?
Yeah, much better.
Awesome. Yeah, no, I'll jump in. I think that actually I can piggyback a bit on Matt and Rob. Arc'teryx is obviously an apparel and equipment company. I think a lot of where our interests lie, obviously materials innovation, but also on the evaluation side. I think one of the questions that we've had in the last couple of years probably has just been that comfort experience and the psychological side of that. And again, like Matt had kind of addressed, there is the sort of biophysical and physiological properties that we're looking at and evaluating, both in a lab, but also in a field context, and how that relates to the comfort experience of the person. And obviously a military application is probably the most severe, but we're designing for people in pretty severe environments as well. So, and also under fairly high physical strain in an athlete scenario, obviously a different context, but similar there. So anyway, I think I'll keep it short. I think that's one of the things that we'd like to focus on if there was opportunity to collaborate. Yeah, that'd be great.
Thank you very much. Any comments, questions for Cam? Great. So who wants to go next? Joan, do you want to go? Please.
Okay. So as I mentioned in the introductions, my background is in nursing, and my research recently has been in the area of health promotion. But in the past, I've also done qualitative research related to patient comfort as an outcome of nursing care. So we've done some conceptual work in that area using qualitative research methods. The other thing that I am interested in and include in my research most recently with health promotion is looking at the influence of sex and gender on experiences related to health. And so by sex, I mean physiological differences between males and females, and that obviously is not necessarily a dichotomy. We even look at muscle mass between men or males and females, it varies. And so I can imagine that that might have an influence on people's comfort under various situations, are sex-related, physiological-related influences. The other influence that we're interested in is also gender influences, and by that I mean, gender identity, gender roles, etc. And so the kind of roles that men and women are in might also influence the way they use particular environments, textiles, whatever. And I would suggest that that might be an important consideration as well. So I might just leave it at that. So I guess my input would be around the human experience of comfort in whatever setting. And of course, I do have some background in clinical care. And so if some of these textiles and environments influence healthcare settings, that might be somewhere that I might be able to provide input as well. So I'll leave it at that. Thank you very much.
Thank you. Any comment, questions?
I think Kevin.
Oh, I had one quick comment for you, Joan, and that was that we also have a female mannequin, that we do have a physiological model associated with it, and there is definitely a difference once you go to start modeling the two of them. As you start working back in the layers, they're very different, very complex animals we are here. So I just wanted to applaud you for bringing that to the forefront and say that's definitely a place we should focus. So
I'm glad to hear that. That's great.
There you go. There you go. That's another novelty, I think, in all the projects. Yeah. I should add also, Joan, myself, and a few other faculty, we are the founding members also of the UBC multidisciplinary undergraduate research on applied health. So we are launching the next one in September. So I can see some of this project we can also define at the undergrad level altogether. So I'll just put it in the chat, the link later. You can look at it. We will announce it later. Who wants to go next? Julian, do you?
Yeah, I can go next. Yeah, please. Okay, let me just share that. You see my screen?
You do. Yes, please.
Okay. All right. So oh, I lost my screen right now. You still see my screen? Sorry.
Oh, disappeared.
Yeah, the computer crashed on it. Sorry about that.
Yeah, it's just coming up.
Whoop. There you go. You see it.
There you go. Yes.
Okay, so I'm more on the pillar number 1 with the cognition and health. So my lab at UBCO, we are looking at the nervous system. So we don't use a mannequin or real human. We use animals, so small rodents for that. And my lab really looks at things that can change the nervous system. So our nervous system is not hardwired. There is a lot of plasticity, and things can change over time. And so we do a different kind of experiments. We can do what we call electrophysiology to look at neuronal activity directly within the brain of the animal. And we can do something we do in collaboration with CPD as well now. It's look at neuronal morphology and things that can affect neurons, that can actually modify the neurons. And all those small structure that you see here, those are basically what will be connections between neurons. And it happens that in the environment, in whatever we do, those connections can change over time. And in all the projects that I hear today that are absolutely fascinating, many questions arose from those are basically what in the environment can modify our nervous system. And I think there's lots of questions we can ask about dust, about the particles from the fabrics. Are they able actually to modify our nervous system? And what we know for sure in rodents is that if you put rodents in a small cage with nothing in the environment, they will not like that. But you can enrich the environment with toys or things like that, and they will like it, and the brain will change. And I think there is good questions to ask on what type of environment can change the brain of an animal. Obviously, it's in the rodent side, and then we can extrapolate that. So in the lab, to answer those kind of questions, we can look at memory. So my lab is really focusing on memory. So we have tests to measure short-term memory and long-term memory in animals, and we can treat animals. So we can look at a modification in their genome or genetic mutation. We can apply drug, but we can also change the environment of those animals and see how that affects their cognitive score on short-term and long-term memory. The second aspect that we do is more about motor skills. So we can do strength tests, coordination, balance, and so we have many different tools that we can use to measure how the animal behave before and after treatments. So to put that quickly in a nutshell, what we do is to look at the development of the nervous system. I talk about the brain, but we can also look at the sensory system. So at the skin level, we did some project before to look how genetic mutation can actually affect the nerves at the skin level. So hearing about the fabric, we can imagine something with animals. Are they responding differently at the skin level with different materials? We can look at neuronal activity and plasticity. We do more biology and biochemistry in neurons. And obviously the one that could be very interesting for those different projects is animal behavior and cognition. That could be on socialization, on breeding, that could be on many different factors we can look at. So just a brief overview of what we do in my lab, but I see a lot of potential for collaboration and to look at actually what's going on with the environment on those animals.
So very, very complimentary, definitely. Any questions, comments for Julian? No, the way I see it, I think your last point was very interesting. You just say the memory or how it just makes it human to perceive the comfort, but it's the other way around as well, like the condition, the textile you wear, it will change your perception.
Yeah.
So
our brain is very plastic, so it changes.
Yeah, that's very interesting. Okay, so let's go next with Richard, please.
Great. Let's come. Okay, well, if you can't see it, that's okay. Looks like it might be, I'm having some difficulties as well. My name is Richard Alliong. I'm an engineering education researcher and interdisciplinary design educator in the School of Engineering. My background, engineering education research, so hearing great ideas from folks and seeing the lab. One of the pillars that I really see with the CREATE program is that focus on teaching and learning, and especially for interdisciplinary collaboration. As Abbas mentioned, this is not a multidisciplinary group, so we're not just hoping to bring together people with diverse perspectives, but we're actually hoping to look for ways that we can leverage and learn from each other to generate new insight around a shared problem. I would even go as far to propose that some of the things we've heard today too is around transdisciplinary topics, thinking about healthy cities and healthy communities, really getting to the space of transdisciplinary challenges. And so my work and research is in qualitative methods, human experience, and making meaning out of individual stories, finding patterns across different perspectives, building relationships between individuals and social and cultural factors that inform and influence the way we do work and the way that we engage with learning and education and our practices. So the second part of my research and area that I'm really excited to bring forward is a focus on how our interdisciplinary teams function and collaborate together to really accelerate and leverage those perspectives and learnings from each other, and supporting our students and our mentees and our training programs to look at the knowledge translation and the ways that we activate knowledge and this research to inform our curriculum, to inform our professional development and the formation of the future generation of scholars and practitioners who will be leading this work. So ultimately, I'm very interested in bringing a human-centered design focus to bring humans to the forefront and the center of what we do, to understand their experience and the meaning that they make when they're engaged in social processes and interacting with our technology. Thank you.
Thank you very much, Richard. Any comments, questions for Richard? I think, yeah, your role will be key on designing the training aspects of our program, because as even faculty, we don't understand, like given the diversity, as you said, transdisciplinary environment here we don't understand each other's language will take a while. We can see from presentation. So let alone the same story in the courses, the students. So your role definitely will be a key. And that's really the final goal when we say the transition of the highly qualified trainees to the industry to cope with the current barriers towards, like overall comfort design. So that starts all with the curriculum design, right? At the first place, for a new program like this. Great. So, Sepida, do you have anything else to add from what you presented?
No, I think we are good with the presentations.
Okay. So you don't have any other specific slides from your research? It's okay. Okay. Farzan, do you have anything specific?
No, yeah, just thank you all. Yes.
Okay. So let me just briefly, like for the record also, I'm sharing, not the right slide. Share again. Yeah. So do you see my slide?
Mm-hmm.
Yeah. So yeah, my lab is more on the composites and optimization, specifically on textile reinforced composites with the polymers, and mainly working on the testing, modeling, simulation, and most recently AI-based optimization of the materials, both at the manufacturing level and the application or structural level. But I think the textile parts, it's really what it lends itself to this group in terms of the lab facility simulations and characterization tools that we have will be the direct kind of relation with this group. So overall, when a new fabric comes to us, in this case on the physical comfort aspects, when we want to characterize it, we have some ready equipment like the ones that we were presented before, mainly on the mechanical side when we discuss about the stretching, for example. But we have some custom built devices such as this one you see in the middle, which is a combined loading device. Our undergraduate students as capstone project designed it, manufactured, and now graduate students as part of this network is using for research. So that means when you do stretching, for example, in mannequin, when you say fit, it's not uniaxial stretch. It's like stretching all directions and at the same time shearing. And we know these fabrics at meso level, they are hierarchical materials. So how we characterize that? There is no commercial fixture for that. We make our own fixture and characterize and then see translated to kind of comfort properties using this multi-mode, if you wish, loading devices. The same thing if there are some additives, chemical additives to it, we have other equipment, characterize it. But all of this then comes to the basic continuum mechanics model so that we can make simulations model out of this basic characterization and the theories, so that now these simulation models at the end of the day can replace the experiments. So we don't need now to do expensive or time-consuming experiments over and over. Be that the same fabric or the new fabrics, we don't need to repeat all the characterization tests. That's kind of the goal. And then apply that simulation, not only at the material level, but also at the application level. So here is a forming of a fabric that's mainly for automotive aerospace, but in our language here is it really stretching. So this can be the human body. Now the textile you're wearing it and you want to mimic how it will stretch and then use it with the other pillars, this model, kind of as a multi-physics model, if you wish. One last thing to add, we also have a micro CT machine on this campus, which can go at the resolution of 1 micron. Here you see an example of a 6-layer glass fiber textile, but it can be any type of textile that it can show at the fiber level. So whatever we see at that macro level properties, if you want to go back to the textile science, see what happens at the fiber level, we can definitely use that. Also for in situ. In situ, what I mean, you can put a small mannequin as it deforms, do the micro CT. That would be a 4D characterization actually over time. So I'll stop there. If you have any specific question for me. Otherwise, we are about half an hour late. And I wanted to thank again all who attended until this last minute, this group and other ones that couldn't attend. Farzan will share the presentation, the video with everyone. But I think the next step, as he showed in the last step, we'll create an online form and share it with everyone, not only industry. Actually, today I gathered we should do it also with our faculty members to kind of write down a few lines. What would be their next ideal kind of project for this group that they want to do? And then we will collect them, kind of assemble them and map it into alliance and create an eminence that we discuss. And maybe from there, sometimes in the fall, we can have a follow-up meeting. But I think it's critical if we have other collaborators, as it was clear in the presentation, please connect them with the Farzan. We want to make sure that we capture everyone in the network. Great, with that, wish you all a great afternoon and thanks again. Eagerly looking forward to the next step.